Hey guys, tonight, we're going to gently brush past the veil of our reality and ask a most peculiar question. What if our planet, this grand blue marble we call home, was not a sphere at all, but rather something far more curious? What if Earth was shaped like a donut? I want you to close your eyes, or simply let your gaze soften and imagine with me. The world as you know it, the solid ground beneath your feet, the curve of the horizon, the way the sun dips below a perfectly round edge each evening. All of it is a beautiful, intricate lie. Instead, our home is a torus, a vast, ring-shaped world spinning in the quiet darkness of space. The light from 1,000 stars would be bent and twisted the passage of a day, a completely alien experience. It's a world that defies our every instinct about up, down, and around. Now, I should give you a small good-natured warning. You'd probably not survive for long on such a world. But for the sake of our little mental journey, let's leave the harsh realities of physics at the door and just wonder. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And as you get settled, I'd be curious to know where you are right now and what time it is for you. In a moment, we'll start our slow, quiet descent into a world that is at once familiar and utterly alien. Our story begins, as all stories must, with a single foundational truth: the pull of gravity. On our spherical Earth, gravity is a simple, elegant force. It draws us inexorably toward the center of the planet, a cosmic tether holding us to its surface. No matter where you stand on a mountaintop or in a deep valley, the force is always pulling you down, a concept so ingrained in our minds that we rarely give it a second thought. But on a donut-shaped Earth, this elegant simplicity is shattered. Imagine our toroidal world, a great ring of rock and water suspended in space. Now visualize its center of mass. It wouldn't be a single point deep within the planet, as it is with our world. Instead, it would be a ring, a circle of gravitational equilibrium, running through the very core of the torus. This simple change from a point to a ring would fundamentally alter everything. For us, this means that the direction of down would be far from uniform. If you were standing on the outer edge of the donut, gravity would pull you toward the center of the ring, a sensation not unlike what we experience now. But as you moved toward the inner edge, the rim of the great cosmic whole, the gravitational pull would shift. It would still draw you toward the center of the torus, but now the ground beneath your feet would feel as if it were sloping upward, an endless gentle hill, rising toward the impossible sky of the inner rim. The very idea of a flat surface would become a relative local concept, not a universal one. This new gravitational landscape would be a scientist's waking dream and a philosopher's endless puzzle. It would be a world where an apple dropped from a tree might not fall straight down, but rather arc inward as if drawn by a hidden force. This is because the gravitational pull would be a complex symphony of forces from every part of the torus, each particle of mass tugging on you with its own tiny voice. The resulting pull, the sum of all these voices, would vary dramatically depending on your exact position. The strongest gravity would likely be found along the outer and inner edges of the donut, where you have the most mass directly beneath you pulling you down in a more conventional sense. The weakest point, a place of near weightlessness, would be right in the middle of the whole. Imagine a great yawning chasm in the center of the world, where gravity is so weak that a single leap could send you floating for minutes at a time. This central region would be a place of strange tranquility, a pocket of cosmic stillness in the midst of a swirling, complex world. Here, the down we know would not exist. Instead, you would be drawn equally in all directions, as if held in the palm of a gentle, unseen hand. To truly understand this, we need to think about a core scientific concept, the principle of superposition. This principle, in the simplest sense, says that the net effect of multiple forces acting on an object is the vector sum of those individual forces. On our spherical Earth, the forces are all pointing toward the center, so the math is relatively clean. But on our donut Earth, the forces are pulling from every direction around the ring. The force from the part of the torus directly below you would be the strongest, but the force from the opposite side of the ring miles away would still be exerting a small sideways pull. The net effect is a gravitational field that is not only weaker in some places, but also has a lateral sideways component that would be felt as a constant, subtle pull. This would make things incredibly strange. For instance, standing on the slopes leading up to the inner rim, you would feel a constant pull inward as if you were forever leaning into the curve. Walking would require a new form of balance, a perpetual adjustment to a force that is never truly straight down. It's in these strange realities that we find some of science's most curious truths. Think of the Coriolis effect, a peculiar force that makes things like winds and ocean currents curve as they travel across the spinning Earth. On our spherical world, it's a beautifully predictable phenomenon. But on a donut, with its complex gravitational field and varied rotational speeds across its surface, the Coriolis effect would be a chaotic, beautiful, and utterly unpredictable dance. Winds would not simply curve to the right or left. They would swirl and eddy in response to the ever-shifting forces, creating weather patterns that would be a complete mystery to any meteorologist from our world. It's a subtle, almost poetic reminder that the universe, in all its complexity, often plays by rules we are only just beginning to understand. This brings us to a beautiful and yet deeply unsettling question. How do we define up and down in a world where gravity doesn't point in a single direction? This isn't just a physics problem, it's a philosophical one. For all of human history, from the first cave drawings to the latest rocket launches, our sense of self and our place in the cosmos has been tied to this simple, singular direction. Up is toward the heavens, down is toward the earth. But what if down was a shifting relative concept? What if, as you walked across the face of your world, the very direction of your own weight, your own being changed with every step? It would force us to question everything. Our architects would need to design buildings that could withstand not only a vertical pull, but a horizontal one. Our maps would need to show not just topography, but also the vectors of gravity, a complex web of arrows indicating the direction of down at every point. Our very language would need to change. We would no longer say up the hill or down the street. Instead, we might talk about moving toward the inner rim or outward toward the wider world. It's a fascinating thought experiment, one that forces us to realize just how much of our reality is built upon a single, seemingly immutable truth. This raises another curious point, a concept that exists on our own spherical Earth, but would be amplified to an almost unimaginable degree on a toroidal one, the gravitational anomaly. On our planet, these are small, subtle variations in gravity caused by differences in rock density mountains or trenches. We use them to find underground resources or to understand tectonic plates. But on a donut world, every topographical feature, every mountain range and ocean trench would create a pronounced and localized gravitational anomaly. A high mountain on the outer rim might have a slightly stronger gravitational pull than a flat plain just a few miles away. The massive swirling ocean currents would themselves create subtle changes in gravity as water masses shifted. It would be a world of constant gentle tugs and pulls, a cosmic dance that would shape everything from the growth of trees to the migrations of animals. A plant might grow with its leaves angled not just toward the sun, but also toward the stronger gravitational pull of a nearby mountain. An animal's sense of direction might be guided not by a magnetic field, but by the subtle shifts in gravity as it moved across the landscape. The entire planet would be alive with these invisible forces, a tapestry woven not just of matter and energy, but of 1,000 tiny pulls. The truth is, we don't really know for sure how life would adapt to such a dynamic environment. It's easy to get lost in the physics of it all to focus on the numbers and the forces. But let's step back for a moment and consider the deeper mystery. Our planet, in its spherical form, is a vessel of unity. It has a single north, a single south. It has a continuous, uninterrupted surface. Our maps are neat, our directions are clear. But a donut Earth is a planet of paradoxes. It has no poles. It has an inside and an outside. It has a sense of continuous motion, and yet in the very heart of its whole, a point of stillness. This duality, this inherent tension between a single form and its divided nature, would permeate everything. It would shape our philosophies, our myths, our very understanding of ourselves. What is a home after all if its foundation is a lie? What if the ground beneath our feet was a constant conversation between opposing forces, a perpetual compromise? A physicist might call it a vector sum, but a poet might call it the very essence of existence, a beautiful, messy, and eternal struggle for balance. The mystery isn't just in the physics of the donut, but in the reflection it casts on our own world and our own perceptions. A donut-shaped Earth is more than just a strange planet. It is a question, a whisper in the night, asking us to look a little closer, to think a little deeper about the familiar world we so often take for granted. As we slowly move away from the puzzle of gravity, let's lift our gaze from the ground and turn it toward the sky. On our familiar spherical Earth, the sun rises in the east and sets in the west, a predictable, comforting rhythm that has guided our lives for millennia. The sky above us is a great dome, a vast canvas across which the constellations and the moon perform their nightly dance. But on our donut-shaped world, this celestial ballet is utterly transformed. The sky, a place of comforting constants for us, becomes a realm of strange and beautiful contradictions. Imagine standing on the outer edge of our toroidal Earth. From here, the sun would still appear to rise and set much as it does for us. But the horizon wouldn't be a simple, elegant curve. It would be a complex line with the great bulk of the donut curving away in one direction and the yawning chasm of the inner rim visible in the other. As the sun rises, its light would spill across this strange landscape, creating shadows and colors we can only dream of. The sky would still be blue, the clouds would still be white, but the context would be entirely new. The sun, as it arced across the sky, would seem to travel a different path depending on your location. Near the equator of the torus, its path would be long and high. But as you moved toward the outer or inner rim, its path would dip lower its light, arriving at a more oblique angle. The seasons we know born of the Earth's axial tilt would be complicated by this new geometry. The sun's position in the sky would be a constant conversation between the planet's tilt and its unique toroidal shape. Now let's travel to the inner rim. This is where the sky gets truly strange. As you climb the gentle gravity-defying slope toward the hole, you would see a sight that no human has ever witnessed, the opposite side of the planet, hanging like a great, impossibly high archway in the sky. It would be a kind of cosmic self-reflection, a permanent reminder that your world is a closed loop. The sun, as it rose, might cast its light on this archway, first illuminating the distant landscapes and making them glow in shades of orange and pink before it even reached you. The sight would be both awe-inspiring and deeply unsettling, a violation of everything we know about horizons and distance. From here, the sun would rise, but it would also appear to set in two directions, as it disappeared behind the outer edge of the torus, and as it passed through the hole. It would create a unique phenomenon, a sort of double dawn and twilight, a moment of profound beauty and confusion. This leads us to a central concept in optics and physics: refraction. On our world, atmospheric refraction makes the sun appear slightly higher in the sky than it actually is, creating those beautiful lingering sunsets. On our donut Earth, this effect would be amplified and distorted. The atmosphere, a great blanket of air, would not be uniform. It would be thinner and stretchier over the outer and inner rims, and thicker and more compressed toward the equator of the torus. As light from a distant star or even the sun itself passed through this irregular atmosphere, it would be bent and warped in ways that would make celestial navigation a complete nightmare. From certain points on the inner rim, you might see a star not as a single point of light, but as a shimmering ghost-like twin, its light bent by the atmosphere and by the sheer gravitational pull of the torus itself. The light, as it traveled across the vast open space of the hole, would be drawn and twisted by the gravitational field, a phenomenon predicted by Einstein's theory of general relativity. A photon of light, a particle with no mass, is still affected by the curvature of space-time created by a large mass. The donut's mass would be a continuous ring, creating a constant gravitational lens that would forever warp the light reaching your eyes. This brings up one of the most fascinating and bizarre scientific facts, the Novikov self-consistency principle, a concept in theoretical physics that suggests that if time travel were possible, it would be impossible to change the past. It's a paradox of cause and effect. On our donut-shaped world, this principle takes on a new, more visceral meaning. The very shape of the planet, a loop with a hole in the middle, is a physical embodiment of a kind of closed loop. You could, in theory, travel in one direction and end up where you started, but in a world where the very light from the sun is bent and twisted by gravity, where the concept of a single linear path is an illusion, the idea of cause and effect of a simple past, present, and future might be something humanity would be forced to reconsider. Would a message sent across the inner rim of the planet arrive at the same time as a message sent around the long way? Perhaps. Would the light from a single event be seen twice, once directly and once as a faint, distant echo, having traveled the long way around the donut? It's a tantalizing thought, a whisper of a universe that is far more complex and interconnected than we can possibly imagine. The truth is, we don't really know for sure if such a world would be a time machine, but it raises an interesting question about the nature of a linear path. The sky, then, on a donut Earth is not a simple canvas, but a living, breathing part of the planet itself. It's a place of strange echoes and visual paradoxes. The sun's journey would be a story told in multiple chapters with different endings depending on where you stood. The moon, a companion we know so well, would be a source of constant bewilderment. As it orbited the torus, its appearance would change not just with its phases, but with its position relative to the hole. From the outer rim, it might look like a regular familiar circle, but from the inner rim, it might appear to arc over the planet's archway, sometimes looking like a perfect glowing ring of its own, as its light was bent and distorted by gravity and atmosphere. It would be a world of shifting, surreal beauty, where the familiar constants of our sky, the very things we rely on to tell time and navigate, would be a cosmic riddle. A simple glance upward would no longer be a moment of quiet contemplation, but a journey into a world of complex physics and beautiful mind-bending geometry. Our ancestors on our world looked to the stars for comfort and guidance. But on this donut Earth, they would look to the sky and find only a question, a constant and beautiful reminder of a reality that is far more complex than a simple sphere. Having gazed at the impossible sky and pondered the strange new rules of gravity, let's now descend to the surface of our toroidal world and ask a most fundamental question. What about life? On our planet, life has evolved in a constant, predictable gravitational field. The very shape of a tree, the skeletal structure of a bird, the way a flower turns its head to the sun, all of it is a quiet testament to the singular downward pull of our home. But in a world where gravity is a complex, shifting symphony, the story of evolution would be rewritten from the very beginning. The first whispers of life would have emerged from a different kind of primordial soup, one bubbling in a strange multi-directional field of force. Imagine the earliest life forms on this donut Earth. On our planet, the first organisms were simple cells floating in a watery ocean, held together by chemical bonds and the gentle, persistent pull of gravity. But on the torus, the oceans themselves would be subject to a complex swirling dance of currents, and the cells within them would have to contend with a gravity that wasn't always down, Perhaps life would have evolved to be more robust, with internal structures that could withstand a lateral pull. Or maybe it would have found a safe haven in the tranquil, near weightless regions of the central hole, where organisms could drift and evolve in a place of cosmic stillness. The very concept of rootedness would change. A tree on our world anchors itself deep into the ground, a single point of stability against the wind and the pull of the earth. But on a donut, a tree might need to grow buttresses in multiple directions, its roots a complex multi-pointed star bracing against a gravity that could shift with the slightest topographical change. It would be a world of perpetually leaning forests and plants that grow in beautiful gravity-defying spirals. This brings us to a core scientific concept: adaptation. On our world, adaptation is about fitting a form to a function within a predictable environment. But on our donut Earth, the environment itself is in constant flux. The forces of evolution then would not just be about surviving a climate or a predator, but about adapting to a constantly changing gravitational reality. A species of flying animal might develop two sets of wings, one for lift and one for steering against the subtle sideways pull of gravity. Their internal organs would need to be held in place by stronger connective tissues, their bones designed not just for support, but for resistance against a world that is always trying to pull them in multiple directions at once. The very act of walking, of putting one foot in front of the other, would require a level of balance and muscular control that we as humans can barely imagine. We would be a clumsy, perpetually stumbling species, forever trying to find our footing on a world that refuses to be still. It's in these subtle changes that we find some of science's most curious and often overlooked truths. Think of proprioception, the sense of self-movement and body position. On our planet, this is a finely tuned sense, allowing us to walk without falling and to know where our limbs are in relation to our body without having to look. It's a sense that relies in part on the predictable, downward pull of gravity. But on our donut Earth, this sense would have to be incredibly acute, a constant internal compass that could detect the slightest shift in gravitational force and adjust our balance accordingly. An organism's proprioception would be a beautiful complex symphony of nerves and muscles, a living barometer of the gravitational landscape. It would be a fascinating example of an internal biological system that has evolved to respond to an external physical anomaly. This raises an interesting question. Would such a species even have a concept of down as a universal truth? Or would it be a local sensory experience, like a kind of feeling in the stomach? The truth is, we don't really know for sure how the brain would process such a sensory reality. The evolution of intelligent life of a species that could build and think and wonder would be a particularly fascinating chapter in this world's story. How would a mind born on a planet without a clear up or down conceive of concepts like north and south or high and low? Their science would be built on a different foundation. Their philosophers would ponder a different set of questions. Their poetry would be filled with metaphors of loops and curves of endless journeys around a world without a beginning or end. They would not see the sky as a great dome, but as a living archway, a continuous bridge between two sides of their world. Their myths and religions would be steeped in this duality, with gods of the inner rim and spirits of the outer edge. A human on this world would be a perpetual traveler, not just across the landscape, but across a spectrum of gravitational and celestial experiences. Remember how we talked about the chaotic, unpredictable dance of the Coriolis effect? This would have a profound impact on the life of this world. The wind and ocean currents, a constant source of life-giving nutrients and climatic balance on our world, would be a swirling vortex of unpredictability on the torus. The deep-sea creatures would live in a world of constant swirling currents, their bodies perhaps more streamlined and flexible to withstand the endless flow. The plants would need to evolve seeds that could travel in 1,000 different directions, their dispersal a beautiful, messy chaos. Even the most fundamental acts of life, like finding food and finding a mate, would be governed by a strange new set of rules. The entire ecosystem would be a dynamic, ever-changing tapestry, a beautiful and terrifying testament to the power of adaptation. What is life, after all, but a constant, beautiful negotiation with the rules of a world we were born into? On our donut Earth, that negotiation would be a perpetual dance, a cosmic conversation between a living organism and the unique, magnificent strangeness of its home. Having explored the grand sweeping changes to life and gravity on a donut Earth, let's now turn our attention to one of its most peculiar and captivating features, the inner world. We've spoken of the great yawning chasm at the heart of the torus, a place of near weightlessness and cosmic stillness. But this hole is not a void. It is in fact a kind of world within a world, a unique ecosystem with its own climate, its own strange biology, and its own laws of physics. It would be a place that challenges our very notions of what a habitable zone can be. Imagine yourself in the heart of this inner world, perhaps floating in a vast, slow-moving ocean that fills the whole. The light here would be unlike anything we know. The sun's rays would stream in from above and below the hole, but they would be filtered and bent by the atmosphere and by the sheer immense mass of the donut itself. The sky, if you can call it that, would be the most surreal sight imaginable, the great curved arch of the planet itself, hanging like an impossible ceiling above you. The inner rim would be a perpetual horizon, a land that seems to rise forever, its mountains and valleys illuminated by a perpetual gentle twilight. This inner world then would be a place of eternal soft glow, a world bathed in reflected light and the faint, strange illumination of a sun that never truly sets, but only shifts its position in the sky. It would be a place of serene, quiet contemplation, a cosmic sanctuary at the heart of a chaotic, spinning world. The atmosphere in this inner world would be a fascinating study in physics. On our Earth, air is densest at sea level and thins as you climb to higher altitudes. But in the central hole of our donut, the gravitational pull would be at its weakest. The air here would be incredibly thin and would not feel like the atmosphere we know. It would feel more like a light mist, a thin veil of gas held in a kind of gentle suspended animation by the forces of the torus. This thin atmosphere would make things like weather and sound behave in strange and wonderful ways. A whisper might travel for miles, its sound waves carried on a current of air that is not being pulled to the ground. Rain would not fall in drops, but might instead form great shimmering sheets of water suspended in the air before slowly, gently coalescing and dripping down toward the weak gravitational pull of the inner rim. The entire environment would be a masterclass in the laws of fluid dynamics, a science that studies the movement of liquids and gases. On our world, these laws are predictable. On the donut Earth, they would be a chaotic, beautiful, and utterly unpredictable dance. This brings us to a fascinating scientific paradox, the twin paradox from Einstein's theory of special relativity. In this thought experiment, one twin travels at near the speed of light, while the other remains on Earth. When the traveling twin returns, they have aged less than the one who stayed behind. On our donut world, this principle takes on a new, more metaphorical meaning. The gravitational pull would vary so dramatically that a person living in the near weightless environment of the inner hole would in a sense be in a different frame of reference from a person living on the outer rim, where gravity is much stronger. The difference in the passage of time would be tiny, almost imperceptible, but it would be there. It would be a poetic truth, a cosmic reminder that even in a world that is a continuous loop, time itself is not always a straight line. This raises a deep and beautiful question. What is the nature of time itself? Is it a universal constant? Or is it like so much else on our donut Earth, a shifting relative experience? The ecology of the inner world would be a true marvel of evolution. Without the constant downward pull of gravity, life would be free to explore forms and functions we cannot even imagine. Plants would not need strong stalks. They could be great floating gardens, their roots a tangle of fibers drifting in the air. There leaves a delicate membrane absorbing the gentle filtered light. Animals would not need heavy bones or powerful muscles. They could be great ethereal creatures, their bodies filled with gas bladders, their movements a slow, graceful dance in the near-weightless atmosphere. The whole place would be a beautiful, vibrant dreamscape, a silent, surreal ballet of life that has evolved to thrive in a world without a solid foundation. The truth is, we don't really know for sure what such life would look like. It is a mystery that is as much a testament to the power of imagination as it is to the laws of physics. So the inner world of our donut Earth is not a simple void. It is a place of profound stillness and strange, beautiful light. It is a sanctuary for a different kind of life, a place where the laws of physics so familiar to us have been bent and rewritten. It is a place that would force us to confront our most basic assumptions about what a planet is and what life can be. It would be a reminder that the universe, in its infinite creativity, can give rise to worlds that are both magnificent and mind-bending, and that our understanding of home is only as limited as our willingness to imagine. We've floated in the strange, near-weightless serenity of the inner world. But now it's time to venture back out to the surface, to the vast, swirling seas of our donut-shaped Earth. On our spherical planet, the oceans are a great interconnected tapestry of currents driven by wind temperature salinity and the predictable pull of the moon. The Gulf Stream, the North Atlantic Current. These are the highways of our oceans, carrying warmth from the equator to the poles and shaping the climate of continents. But on our toroidal world, the oceans would be a far more complex and mesmerizing sight, a world of powerful double currents and a ceaseless beautiful chaos. Imagine the great ring of water that would encircle our planet. It would not be a single uniform body, but rather two distinct oceans, an outer ocean on the wide outer curve of the torus, and an inner ocean on the narrower inner rim. These two oceans would be connected by powerful churning currents that flowed around the planet, but also by a constant slow exchange of water that would flow up the slopes of the inner rim and down the slopes of the outer edge. The forces at play here would be immense. The planet's spin would create a Coriolis effect that would drive a massive planetary scale current, a great river of water that would flow endlessly around the donut. But this wouldn't be a simple single current. The varied gravitational pull would create a series of eddies and countercurrents, a complex dance of water that would be a source of constant wonder and peril. The most unique and powerful feature of this oceanic system would be the double current. Visualize the ocean's surface. On the outer rim, a massive, powerful current would flow driven by the planetary spin and a relatively uniform gravitational pull. But on the inner rim, a second equally powerful current would flow in the opposite direction, driven by a different set of forces. This is because the gravitational pull toward the center of the torus would create a kind of high tide along the outer and inner edges and a kind of low tide along the equator of the torus. This difference in water level would create a constant slow flow of water from the high tide regions to the low tide regions, a flow that would be amplified and distorted by the planet's rotation. The result would be a world of powerful swirling gyres, a place where a ship could be caught in a current for months traveling endlessly around the ring, or could be swept into a perilous vortex where the two currents meet. It would be a sailor's dream and a cartographer's nightmare, a world where the sea is a living, breathing entity with its own incomprehensible will. This leads us to a crucial concept in physics and chemistry: thermal energy transfer. On our spherical Earth, the ocean currents play a vital role in regulating our planet's climate. They carry warm water from the equator to the poles, releasing that warmth into the atmosphere and preventing the equatorial regions from overheating and the polar regions from freezing. But on our donut Earth, this process would be profoundly altered. The double current would create a complex exchange of heat with warm water from the sun-drenched outer rim being carried to the cooler inner rim, and cooler water from the inner rim flowing outward. The result would be a world of bizarre and often beautiful temperature zones. One side of a continent could be bathed in a warm current, while the other side, just a few miles away, could be chilled by a countercurrent. The entire planet would be a mosaic of different climates, a tapestry woven not just of land and sea, but of temperature and currents. The truth is, we don't really know for sure what kind of climate would emerge from such a complex system. It is a mystery that is as much about the planet's geography as it is about the physics of water. The marine life of our donut Earth would be a testament to the power of adaptation. Fish and other sea creatures would have to contend with a world of constant, swirling currents. Their bodies would likely be more streamlined, their fins more powerful. They might evolve a sense of direction that is tied not just to the planet's magnetic field, but to the subtle shifts in gravity and the flow of the currents. Think of the magnetic field reversal that our own planet has experienced many times throughout its history. This is a scientific fact that has led to some fascinating theories about the migrations of animals and their reliance on the Earth's magnetic field. On our donut world, with its complex multi-directional gravity, the magnetic field would be a far less reliable guide. Life would need to find other ways to navigate other ways to find its way home. So the oceans of our donut Earth are not a simple body of water, but a living, breathing part of the planet itself. They are a world of double currents and strange, beautiful gyres, a place where the laws of fluid dynamics are rewritten in a language of water and force. They are a reminder that the universe in all its complexity can create worlds that defy our every expectation and our every assumption about the natural world. What is an ocean, after all, if its currents are a paradox, a story of two different journeys happening at the same time? It is a question that, like the whisper of a soft current, we will ponder for a long time. We have navigated the strange seas and contemplated the unique life forms of our toroidal world. Now let's consider the air itself, the great swirling blanket of atmosphere that would clothe this magnificent, impossible planet. On our spherical Earth, the climate is a dance of predictable, well-defined zones. The hot equator, the temperate mid-latitudes, and the cold poles. But on a donut Earth, with its complex gravitational fields and its double currents, the climate would be a woven tapestry of 1,000 different threads. A beautiful, unpredictable mosaic of weather and temperature. Imagine the atmosphere of the torus. It wouldn't be a uniform shell of air. The weakest gravitational pull in the center of the hole would allow the atmosphere to bulge outward, creating a kind of atmospheric hill. The strongest pull along the outer and inner edges would create valleys of compressed, dense air. This difference in atmospheric pressure, combined with the planet's rotation and the unique currents of its oceans, would create a weather system unlike anything we know. The winds would not simply blow from high pressure to low pressure in a straight line. They would be bent and twisted by the subtle sideways pull of gravity and by the great swirling vortexes of the double ocean currents. It would be a world of powerful, unpredictable winds of storms that could rage for months in a single circular gyre. The seasons, a concept so central to our lives, would be profoundly altered. Our seasons are caused by the tilt of our planet's axis, which changes the angle at which sunlight hits different parts of the Earth. But on a donut Earth, this tilt would be just one of many factors. The unique geometry of the torus would mean that some parts of the planet, the inner rim for instance, would always receive a more oblique and therefore weaker kind of sunlight. The outer rim, with its wider curve, would be more exposed to the sun's direct rays. The result would be a planet of permanent climatic zones, but with a twist. The traditional seasons we know would be replaced by a different kind of cycle, a slow, subtle shift in temperature and weather as the planet orbited its star. It would be a world where some places were forever in a gentle autumn, while others were in a perpetual spring. A world where the concept of a hot summer or a cold winter might not exist at all, but rather a slow, poetic shift between seasons we can only imagine. This brings us to a core concept in the study of weather and climate, the Hadley cell. On our planet, These are vast global loops of air circulation that carry warm moist air from the equator to the mid-latitudes and cool dry air back to the equator. But on our donut Earth, the Hadley cells would be a complex multi-layered system. There would likely be a cell that flows around the entire torus, but there would also be smaller, more localized cells that flow from the inner rim to the outer rim and back again. The result would be a climate system that is less like a single grand circulation and more like a series of interconnected swirling eddies, each one with its own unique weather patterns and its own subtle influence on the planet as a whole. This raises a beautiful and yet deeply unsettling question. What would the weather forecast be like on such a planet? It would be a probabilistic philosophical art form, a constant negotiation with a climate that is, in a very real sense, alive. The truth is, we don't really know for sure what such a climate would feel like, or what kind of life would thrive within it. Think back to the gravitational anomalies we spoke of earlier. These subtle shifts in gravity, caused by mountains and oceans, would also have a profound impact on the weather. A mountain range on the outer rim might create a kind of permanent rain shadow, a dry, arid region on its lee side, while a similar mountain range on the inner rim might create a fog shadow, a perpetually misty region on its windward side. The entire planet would be a mosaic of microclimates, a tapestry woven not just of temperature and wind, but of gravity and topography. A person could walk 100 miles and experience a dozen different climates, each one a unique and beautiful expression of the planet's strange, magnificent form. This all leads us to a beautiful and yet deeply unsettling philosophical question. What is the nature of home on a planet with no north or south? Our sense of home, of a place we belong, is often tied to a sense of direction of a place on a map. But on a donut Earth with its endless loop and its constantly shifting climates, the very concept of a fixed, permanent home might be a delusion. Perhaps home would not be a place but a feeling of belonging to a certain current, a certain wind, a certain kind of light, a feeling that, like the planet itself, is always in motion, always changing, always seeking a new kind of balance. It would be a world that forces us to let go of our most fundamental assumptions about direction and to find a new kind of compass, an internal one that is guided not by a pole, but by the quiet whispers of the wind. We have journeyed through the strange and beautiful weather patterns of our donut Earth, a world where winds and currents dance to a different tune. Now let's turn our gaze to the most remarkable creature on this impossible planet, humanity itself. On our spherical Earth, our ingenuity is a testament to our ability to overcome physical limitations. But on a toroidal world, our challenges would be of a different and perhaps more profound nature. How would we, as a species, build cities, navigate the world, and organize our societies in a place with no north or south pole, no straight horizon, and no single direction of down? Imagine the great cities of the torus. On our world, a city is a testament to a single vertical line of gravity. Buildings rise, straight up streets run straight, and the concept of a grid is a foundational principle. But on a donut Earth, a city would be a work of art, a perpetual negotiation with a shifting gravitational field. Buildings would be constructed with a subtle, inward lean. Their foundations braced not just against the weight of the structure, but against the constant, subtle sideways pull toward the center of the torus. The streets would not be straight. They would be great curving avenues that follow the lines of gravitational equilibrium, creating a city that feels like a vast, winding spiral. Our architects would be artists of a new kind, masters of a fluid, dynamic form of construction. Our engineers would need to calculate not just the downward force of gravity, but its complex, multi-directional vector at every point. The very concept of a skyscraper would be a breathtaking and terrifying challenge, a tower that leans just slightly inward, a perpetual monument to a world that refuses to be simple. This brings us to a core scientific concept, stress and strain. In engineering, These concepts are about how materials respond to force. On our world, a building's stress and strain are primarily from the downward pull of gravity and the lateral force of wind. On our donut Earth, a building would be subjected to a constant, subtle, multidirectional stress, a perpetual tug of war between the different gravitational forces of the torus. The materials we use to build would need to be incredibly flexible and strong, able to withstand a world that is always trying to pull them apart in a dozen different ways. It's a fascinating thought experiment, one that forces us to reconsider the very nature of structural integrity. A building would no longer be a static monument, but a living, breathing part of the planet itself, constantly adjusting and adapting to the subtle shifts in the world around it. The truth is, we don't really know for sure if our materials science would even be up to the task. It's a mystery that is as much about our ingenuity as it is about the laws of physics. Navigating this world would be a profound and beautiful challenge. On our Earth, we rely on the magnetic poles on the stars and on a global system of latitude and longitude. But on a donut, with its complex gravitational field and its bizarre celestial sights, these tools would be useless. A compass would spin wildly, unable to find a single pole. The stars warped by gravity and atmospheric refraction would be a source of confusion, not guidance. Our cartographers would need to create a new kind of map, one that shows not just the topography of the land, but also the vectors of gravity. A complex web of arrows indicating the direction of down at every point. We would need to navigate by a new kind of internal compass, a sense of direction that is tied not to the poles, but to the feeling of gravity beneath our feet. We would become a species of perpetual navigators, our minds and bodies constantly adjusting to a world that refuses to be still. Remember how we talked about the principle of superposition in the first section? This would have a profound impact on how we organize our societies. On our world, our societies are often organized around a central point, a capital city, or a geographic center. But on a donut, with its ring-shaped geography and its multi-directional gravitational field, the concept of a single center would be a lie. Our societies would likely be organized around a different principle, a principle of continuous connection. There would be no capital city. There would be a series of interconnected cities, a great ring of civilization that mirrors the shape of the world itself. Our cultures would be a beautiful complex tapestry of different ideas with a constant flow of people goods and information circulating around the great loop of the torus. The entire planet would be a single interconnected community, a world that by its very nature refuses to be divided. This raises an interesting philosophical question. Would such a world be free of conflict? Would a species that is constantly reminded of its own interconnectedness be able to wage war on itself? It is a mystery that, like so much else on our donut Earth, is a reflection of our own hopes and fears. So the humanity of our donut Earth is not a simple copy of ourselves. It is a new kind of being, a species that has been shaped by a world that defies our every assumption. We would be builders of a new kind of architecture, navigators of a new kind of sea and sky, and members of a new kind of society. It is a world that by its very nature would force us to become more connected, more adaptable, and more curious. What is humanity, after all, if it is not a creature of constant reinvention, a species that is always seeking a new way to build, to navigate, and to find its place in the cosmos? We have imagined the great cities and the unique societies of our donut Earth. Now let's travel back in time to the very beginning of this impossible world and consider its history and geology. On our spherical Earth, our history is a story of tectonic plates grinding against each other, of mountains rising and falling, and of continents drifting across a vast ocean. The geology of our planet is a record of these events, a grand, slow-moving narrative written in rock and stone. But on a toroidal world with its complex gravitational fields and its unique ring-shaped core, the story of the planet's birth and its subsequent evolution would be rewritten from the ground up. Imagine the birth of this world, a great swirling cloud of gas and dust collapsing in on itself. But instead of forming a single elegant sphere, it forms a great ring. The forces at play here would be immense and complex. The material of the nascent planet would be pulled not just toward a single center, but toward a ring of gravitational equilibrium, a perpetual tug of war that would shape the planet into its final improbable form. The molten core of this world would not be a single spinning sphere of iron and nickel, but a great continuous ring of magma, a cosmic engine of immense power. This ring would be the source of the planet's magnetic field and the force that drives its tectonics. The truth is, we don't really know for sure if such a core could even exist, or what kind of magnetic field it would produce. It is a mystery that is as much about the laws of physics as it is about the power of imagination. The tectonic plates of our donut Earth would be a fascinating study in geology. On our planet, the plates are great rigid slabs that float on a layer of semi-molten rock, their movement driven by the heat of the core. But on a donut, with its ring-shaped core, the plates would be far more complex. There would likely be a series of plates that run along the length of the torus, but there would also be smaller, more chaotic plates that are caught in the gravitational eddies of the inner rim and the outer edge. The movement of these plates would not be a simple linear drift. It would be a swirling circular dance, a constant, beautiful chaos of subduction zones and mountain-building events. A mountain range on the outer rim might be a long continuous chain, a monument to a single powerful collision. But a mountain range on the inner rim might be a strange chaotic jumble of peaks and valleys, a testament to 1,000 smaller, more complex collisions. This brings us to a core scientific concept, volcanism. On our planet, volcanoes are the vents through which the Earth releases its internal heat and pressure often found along the edges of tectonic plates. But on our donut Earth, the volcanism would be a far more complex and beautiful phenomenon. The great ring-shaped core of magma would create a continuous volcanic ring of fire, a series of volcanoes that erupt along the entire length of the torus. This would be a world of constant, beautiful eruptions of great plumes of ash and smoke that rise into a sky that is already a place of strange and beautiful contradictions. The entire planet would be a living, breathing testament to the power of its own internal forces, a world that is constantly being born and reborn. Remember how we talked about the principle of superposition. This would have a profound impact on the planet's geological history. The forces that shape the planet's surface would not be a simple single event, but a complex, multi-layered tapestry of collisions and eruptions. A mountain range might be formed by a tectonic collision, but its final shape would be sculpted by the subtle, multi-directional pull of gravity and the constant swirling winds of the atmosphere. The entire planet would be a work of art, a masterpiece of 1,000 different forces, each one leaving its own unique mark on the world. This raises an interesting question. Would such a world have a geological record that we could even understand? It would be a story written in a language we can only begin to decipher. So the history of our donut Earth is not a simple linear narrative, but a great swirling epic of fire and stone. It is a world that has been shaped by forces we can barely imagine, a world that is in a constant state of beautiful, chaotic creation. It is a world that by its very nature would force us to let go of our most fundamental assumptions about the nature of our planet, and to find a new kind of beauty in a world that refuses to be simple. What is a history after all? If it is not a story of constant reinvention, a testament to the power of a world that is always seeking a new way to be, we have delved into the deep geological history of our donut Earth, a world born from fire and shaped by forces we can only imagine. Now let's turn our attention to one of its most beautiful and mind-bending phenomena, the whispers of a double dawn. We've spoken of the sun's strange journey across the sky, but there is a more subtle and perhaps more profound aspect to the light of this world. In a world where the planet's own shape creates a kind of gravitational lens, The light itself becomes a storyteller, a cosmic echo of a reality that is far more complex than we know. Imagine standing on the inner rim just before the sun is set to rise. You would see a sight that no human has ever witnessed: a faint, ghost-like ring of light in the sky. This is not the sun itself, but rather the sun's light being bent and refracted by the atmosphere and gravity of the far side of the planet, the light having traveled the long way around the great loop of the torus. It would be a kind of celestial echo, a premonition of the dawn to come. As the sun begins to rise over your own horizon, this ghost light would grow brighter, a beautiful, impossible ring of fire that mirrors the shape of your world itself. This would be the first dawn, the whisper of a new day. The second dawn, the true dawn, would come moments later as the sun itself rose over the horizon and its light flooded the land. The entire experience would be a beautiful, complex conversation between light gravity and the unique, magnificent geometry of the world. This brings us to a core scientific concept: gravitational lensing. We know from Einstein's theory of general relativity that mass bends space-time. The light from a distant star, as it passes by a massive object like a galaxy, is bent and distorted, creating a series of beautiful ghost-like images of the same star. This is gravitational lensing, a phenomenon that has allowed us to see galaxies that are billions of light years away. On our donut Earth, this same principle would be at play, but on a much smaller, more personal scale. The great massive ring of the torus would act as a kind of permanent gravitational lens, bending and refracting the light from the sun and the stars, creating a world of beautiful visual paradoxes. The sun's light, as it traveled around the great loop, would be bent and distorted, creating the ghost-like double dawn that we spoke of. The light from a distant star might be seen twice, once as a direct image and once as a faint, ethereal echo. It would be a world where seeing is not always believing, a world that is a living, breathing testament to the power of a universe that is far more complex than we can possibly imagine. The cultural and scientific implications of this would be immense. For a species that has grown up with a double dawn, the very concept of a single linear day would be a foreign one. Their myths and religions would be steeped in this duality, with stories of a ghost sun and a real sun of two different dawns that herald a single day. Their science would be built on a different foundation, a foundation of paradox and complexity. A scientist from this world would not see light as a simple straight line, but as a fluid, dynamic entity that is constantly being bent and shaped by the world around it. The very act of looking at the sky would be a constant reminder that their world and their reality is a beautiful, interconnected, and deeply mysterious place. The truth is, we don't really know for sure how such a species would think or what kind of science they would create. It is a mystery that is as much about the nature of the mind as it is about the laws of physics. Remember how we talked about Novikov's self-consistency principle and the paradox of time travel. The double dawn of our donut Earth is a kind of visual embodiment of this principle. The light you see is an echo of a past moment, a light that has traveled a longer, more circuitous path to reach you. It is a reminder that in this world, the past and the present are always in a kind of conversation, a beautiful, complex dance of light and time. It would be a world that forces us to let go of our most fundamental assumptions about the linearity of time and to find a new kind of beauty in a world that is a perpetual, magnificent echo of its own history. So the double dawn of our donut Earth is more than just a beautiful sight. It is a profound mystery, a cosmic paradox, and a testament to the power of a world that refuses to be simple. It is a reminder that the universe, in all its complexity, can give rise to worlds that challenge our every assumption and force us to find a new kind of wonder in the familiar. We have seen the strange and beautiful whispers of a double dawn. Now let's leave the surface of our planet and journey into the very fabric of its existence. We are no longer scientists looking at the outside of a world, but rather philosophers of a new kind, pondering the very physics that makes this magnificent paradox possible. What is it about this world with its impossible shape and its complex gravitational fields that forces us to reconsider the most fundamental laws of the universe? On our spherical Earth, the laws of physics are elegantly simple. Gravity is a force that pulls us toward a single point. Time is a straight line. Space is a vast open expanse. But on our donut Earth, all of these simple truths are shattered. The very shape of the planet, a loop with a hole in the middle, is a challenge to our most fundamental understanding of geometry and topology. A geometer on this world would not speak of a sphere, but of a torus, a shape that has no center, no poles, and no straight lines that don't eventually curve back in on themselves. A traveler on this world would not speak of a linear journey, but of a circular one, a perpetual quest that always brings you back to where you started. The entire planet would be a physical embodiment of a kind of closed-loop reality, a world that is in a very real sense a kind of cosmic Ouroboros, an endless serpent eating its own tail. This brings us to a core concept in physics: space-time curvature. We know from Einstein's theory of general relativity that mass and energy warp the fabric of space-time, creating the effect we call gravity. On our spherical Earth, this warping is relatively uniform, a gentle downward curve that holds us to the surface. But on our donut Earth, the space-time curvature would be far more complex. The great massive ring of the torus would create a continuous multi-directional warping of space-time, a beautiful complex field of gravitational forces that would pull and push and twist everything in its path. The light from a distant star, as we have already discussed, would be bent and distorted. The orbit of a moon would be a strange, chaotic dance, not a simple ellipse. A satellite, if one could even be launched, would not follow a simple, predictable path, but would instead be caught in a beautiful, complex ballet of gravitational forces, a perpetual negotiation with a world that refuses to be simple. Think back to the twin paradox from our discussion of the inner world. This is not just a thought experiment. It is a real effect of space-time curvature. The stronger the gravity, the slower time passes. In our donut world, with its constantly shifting gravitational fields, the passage of time would be a beautiful, complex tapestry. A person living on the outer rim, where gravity is strongest, would age ever so slightly slower than a person living in the near weightless environment of the inner hole. The difference would be infinitesimal, a fraction of a second over a lifetime, but it would be there. It would be a poetic truth, a cosmic reminder that in this world, time itself is not a universal constant, but a personal relative experience, a beautiful and complex reflection of the world you inhabit. This raises a deep and beautiful question. If the passage of time is a personal experience, what is the nature of a shared moment? The truth is, we don't really know for sure what such a species would think about time. It is a mystery that is as much about the nature of consciousness as it is about the laws of physics. So the physics of our donut Earth is not a simple, elegant set of laws. It is a beautiful, complex, and deeply mysterious conversation between matter, energy, and the very fabric of space-time itself. It is a world that by its very nature would force us to let go of our most fundamental assumptions about the universe and to find a new kind of wonder in a world that refuses to be simple. What is a law of physics after all, if it is not a story of constant reinvention, a testament to the power of a universe that is always seeking a new way to be? We have considered the strange physics of our donut Earth, a world where the very fabric of space-time is a complex, beautiful tapestry. Now let's leave the grand scale of planetary forces and turn our gaze to the heavens once more, to the night sky that would hang above this impossible world. On our spherical Earth, the night sky is a familiar, comforting dome, a great canvas on which the constellations perform their nightly dance. But on a toroidal world, the night sky would be a source of profound wonder and confusion, a place where the familiar rules of celestial mechanics are bent and broken. Imagine standing on the outer rim of the torus on a clear night. You would see a sky that is both familiar and alien. The stars would still be there, the distant suns and galaxies, but their positions and movements would be profoundly altered. The horizon would not be a single elegant curve. It would be a complex line with the great bulk of the donut curving away in one direction and the yawning chasm of the inner rim visible in the other. As the planet rotates, the stars would not simply arc across the sky in a predictable path. Their movements would be a complex, beautiful dance, a perpetual conversation between the planet's rotation and its unique, magnificent geometry. You might see a constellation rise in the east, only to see it appear to dip and then rise again as it passed behind the great curving arch of the inner rim. The entire night sky would be a living, breathing testament to the power of a world that refuses to be simple. This brings us to a core concept in astronomy celestial mechanics. On our planet, celestial mechanics is the study of the movements of the stars and planets, a field that has allowed us to predict eclipses and chart the course of our universe. But on our donut Earth, celestial mechanics would be a chaotic, beautiful, and utterly unpredictable dance. The great massive ring of the torus would create a complex gravitational field that would constantly pull on the moon and the other planets, altering their orbits and making their movements a source of constant bewilderment. A moon that orbits the torus would not follow a simple circular path. It would be caught in a perpetual tug-of-war between the different gravitational forces of the outer and inner rims. Its orbit, a strange, chaotic dance that would be a source of constant wonder and peril for any astronomer from our world. The truth is, we don't really know for sure how the night sky would look or what kind of science a species on this world would create to understand it. It is a mystery that is as much about the nature of the mind as it is about the laws of physics. Think back to our discussion of gravitational lensing and the double dawn. This same principle would be at play in the night sky. The light from a distant star as it passed by the great massive ring of the torus would be bent and distorted, creating a series of beautiful ghost-like images. You might see a constellation not as a single beautiful pattern, but as a series of shimmering ghost-like echoes. You might see a single star appear in two different places at the same time, its light having traveled two different paths to reach your eyes. It would be a world where seeing is not always believing, a world that is a living, breathing testament to the power of a universe that is far more complex than we can possibly imagine. This raises an interesting philosophical question. What is a star map in a world where the stars are not where they seem to be? It would be a work of art, a beautiful complex tapestry of light and gravity. The night sky of our donut Earth would be a source of profound mystery and beautiful paradox. It would be a world where the familiar rules of celestial mechanics are bent and broken, a world where the stars are not just a source of light, but a source of constant wonder and confusion. It would be a world that by its very nature would force us to let go of our most fundamental assumptions about the universe and to find a new kind of wonder in a world that refuses to be simple. What is a night sky, after all? If it is not a story of constant reinvention, a testament to the power of a universe that is always seeking a new way to be. We have stared into the magnificent and strange night sky of our donut Earth, a world where the familiar constellations are bent and broken by gravity. Now let's leave the grand celestial canvas and turn inward to the human soul itself. What does it mean to be human on a planet that defies our most fundamental assumptions about direction, home, and unity? On our spherical Earth, our sense of self is tied to a single elegant truth. We are creatures of a single continuous surface, a world with a clear north and south, a world that is in a very real sense a single unified whole. But on a toroidal world, the human experience would be a beautiful complex labyrinth of paradoxes. Imagine the philosophers of this world. They would not speak of a linear path from birth to death, but of a circular one, a journey that always brings you back to where you started. They would not speak of a single unified cosmos, but of a world with an inside and an outside, a universe that is a beautiful paradoxical mirror of their own home. Their myths and religions would be steeped in this duality, with stories of a journey that must be taken in two directions at once, a quest that is both a search for a single unified truth and a celebration of a beautiful, multifaceted reality. The entire human experience would be a constant negotiation with a world that refuses to be simple, a perpetual search for meaning in a place that is by its very nature a cosmic riddle. The truth is, we don't really know for sure how such a species would think or what kind of philosophies they would create. It is a mystery that is as much about the nature of consciousness as it is about the laws of physics. This brings us to a core concept in philosophy and psychology, the self. On our planet, the self is a unified, coherent entity, a single consciousness that experiences a single, linear reality. But on our donut Earth, the self would be a far more complex and beautiful thing. It would be a self that is constantly in conversation with a world that is pulling it in a dozen different directions at once. It would be a self that has to negotiate a constantly shifting gravitational reality, a self that has to find a new kind of balance, both physical and spiritual. The very concept of a single unified self might be a delusion, a beautiful lie that a species on this world would have to learn to let go of. Perhaps the self would not be a single point, but a great swirling vortex of experiences, a beautiful complex tapestry of emotions, thoughts, and feelings that are constantly in conversation with the world. Think back to the Coriolis effect and the chaotic dance of the winds and currents. This would have a profound impact on the human psyche. We as humans are creatures of pattern and predictability. We find comfort in the rhythm of the tides, in the predictable movement of the stars. But on a toroidal world, with its chaotic, beautiful, and utterly unpredictable dance of wind and water, the human mind would have to learn to find comfort in chaos. We would have to learn to let go of our need for a single predictable truth and to find a new kind of beauty in a world that is always in motion. This raises an interesting philosophical question. Would such a species be more resilient than us? Would a species that is born into a world of constant change be able to withstand the chaos of the universe in a way that we as creatures of a single predictable world cannot? So the labyrinth of the soul on our donut Earth is not a simple single path, but a great swirling epic of paradox and beauty. It is a world that would force us to let go of our most fundamental assumptions about the nature of the self and to find a new kind of wonder in a world that refuses to be simple. What is a soul after all? If it is not a story of constant reinvention, a testament to the power of a being that is always seeking a new way to be, we have explored the labyrinth of the soul on our donut Earth, a world that would force us to redefine what it means to be human. Now let's go back even further to a time before life, before even the planet itself had fully formed. What is the story of this world's origins? On our spherical Earth, our creation stories are steeped in a kind of elegant simplicity. A great cloud of gas and dust collapses into a single elegant sphere, a grand singular act of cosmic creation. But on a toroidal world, the story of its birth would be a far more complex and beautiful tale, a testament to the power of forces that we are only beginning to understand. Imagine a great swirling nebula of cosmic dust and gas, a vast, beautiful cloud of potential energy. Instead of collapsing into a single spherical center, this cloud, for reasons we can only speculate about, begins to spin with a kind of internal toroidal momentum. The particles of dust and gas do not spiral inward toward a single point, but rather they begin to coalesce around a great circular ring. The forces at play here would be immense: the pull of gravity, the outward force of the planet's spin, and the complex, beautiful dance of 1,000 different particles colliding and coalescing in a way that defies our most fundamental assumptions about planetary formation. It would be a kind of cosmic ballet, a dance of creation that is at once chaotic and profoundly beautiful. This brings us to a core scientific concept: accretion. On our planet, accretion is the process by which a planet grows a slow patient accumulation of dust and rock that eventually forms a single massive body. But on our donut Earth, the accretion process would be a far more complex and beautiful thing. The particles of dust and gas would not simply fall toward a single central point. They would be caught in a perpetual swirling vortex, a great ring of cosmic material that is constantly colliding and coalescing, slowly building a world in the shape of a loop. The process would be far more violent and far more chaotic, a world being born not from a single elegant act of creation, but from a million different collisions, 1,000 different acts of cosmic violence. It would be a world that is, in a very real sense, a kind of living, breathing testament to the power of chaos. Think back to the magnetic field reversal we spoke of earlier. On our planet, this is a slow, patient process that takes thousands of years. But on our donut Earth, with its great swirling ring of a molten core, the magnetic field would be a far more complex and chaotic thing. It might not have a north and south pole at all, but rather a series of poles that are constantly shifting and changing a magnetic field that is a beautiful, complex reflection of the chaotic swirling forces of the core. This would have a profound impact on the planet's history, on the evolution of life, and on the very nature of time itself. It is a mystery that is as much about the laws of physics as it is about the power of imagination. So the question of our origins on a donut Earth is not a simple single story. It is a great swirling epic of paradox and beauty. It is a world that would force us to let go of our most fundamental assumptions about the nature of creation and to find a new kind of wonder in a world that refuses to be simple. What is a creation story after all? If it is not a story of constant reinvention, a testament to the power of a universe that is always seeking a new way to be. We have considered the strange and beautiful origins of our donut Earth, a world born from chaos and shaped by forces we can only imagine. Now let's take a step back from the grand sweep of history and the grand scale of physics and gently bring our journey to a close. We have imagined a world that defies our every assumption, a world of paradox and beauty. But what does this impossible world, this cosmic riddle, have to say about our own home? This grand blue marble that we so often take for granted. As we begin to wind down, let's reflect on the things we have learned, not about the donut Earth, but about our own. We have talked about gravity and how a simple, elegant downward pull is the foundation of our entire reality. On our donut Earth, gravity was a complex, shifting symphony of forces. But on our world, it is a single beautiful truth that holds us to the ground, a constant comforting presence that we rarely even think about. We have talked about the sky and how a double dawn and a single sun would create a world of visual paradoxes. But on our world, the sun rises in a single elegant path, a predictable, comforting rhythm that has guided our lives for millennia. We have talked about a world with no north and south, a world where the concept of home is a beautiful, complex labyrinth. But on our world, the poles are a single elegant truth, a magnetic guide that has allowed us to navigate the world and find our way home for centuries. This brings us to a core scientific concept, the familiar. On our planet, the familiar is often a source of comfort, a place where we feel safe and secure. But on our donut Earth, the familiar would be a source of constant bewilderment, a world where the rules are always changing and the ground is never truly still. This raises an interesting philosophical question. Is the familiar a source of comfort, or is it a kind of prison? Is it a place where we feel safe, or is it a place where we have stopped asking questions? The truth is, we don't really know for sure, but it is a question that our journey to the donut Earth has forced us to confront. Remember how we talked about Novikov's self-consistency principle and the paradox of time travel. Our journey to the donut Earth is a kind of mental time travel, a journey into a world that never was. But in doing so, we have come to a deeper understanding of the world that is. We have seen that the simple, elegant truths of our world, gravity, time, space, are not simple at all. They are a beautiful, complex, and deeply mysterious conversation between matter energy and the very fabric of space-time itself. We have seen that our world in all its familiarity is a kind of cosmic miracle, a beautiful and complex paradox that we are only just beginning to understand. So the familiar is not a prison, but a kind of cosmic gift. It is a place where we can feel safe and secure, a place where we can stop and rest before we once again turn our gaze to the stars and begin to ask new questions. What is a home after all? If it is not a place where we feel safe enough to wonder, to dream, and to ask the impossible questions that lead us to a deeper understanding of ourselves and our place in the cosmos, we have completed our long and strange journey to the donut Earth, a world that exists only in the quiet, curious spaces of our imagination. We have asked impossible questions and found beautiful, complex answers. But now it is time to gently bring our thoughts back to our own world, to this grand blue marble that spins in the quiet darkness of space. As we slowly, softly return to the familiar, let's take a moment to reflect on the most profound mystery of all, the universe itself. We have spent our time imagining a world of paradoxes, a world with no north or south, no single direction, of down, and a sky that is a source of constant bewilderment. But our own world is also a world of paradoxes, a place of profound and beautiful contradictions. It is a world of light and shadow, of life and death, of chaos and order. It is a world that is, in a very real sense, a kind of cosmic riddle, a beautiful, complex tapestry of forces and energies that we are only just beginning to understand. The same laws of physics that would make a donut Earth a strange and beautiful paradox are the very same laws that make our own world a place of such breathtaking beauty and profound mystery. This brings us to a core scientific concept, the unknown. On our planet, the unknown is often a source of fear, a place where we are afraid to go. But on our donut Earth, the unknown was a source of constant wonder, a place where we were forced to ask new questions and to find new ways of thinking. This raises a beautiful and yet deeply unsettling philosophical question. Is the unknown a source of fear? Or is it a source of wonder? Is it a place where we are afraid to go? Or is it a place that we are destined to explore? The truth is, we don't really know for sure, but it is a question that our journey to the donut Earth has forced us to confront. Remember how we talked about the labyrinth of the soul? Our journey to the donut Earth was a kind of journey into our own souls, a journey into the quiet, curious spaces of our minds where we dare to ask impossible questions. We have seen that the human mind is not a simple single path, but a great swirling epic of paradox and beauty. We have seen that we as humans are creatures of constant reinvention, a species that is always seeking a new way to be. We have seen that the most profound mystery of all is not the universe itself, but our own consciousness, our own ability to ask questions, to imagine new worlds, and to find a new kind of wonder in the familiar. So the universe is not just a place of stars and galaxies. It is a place of paradoxes and riddles, a place of profound and beautiful contradictions. It is a place that by its very nature forces us to let go of our most fundamental assumptions and to find a new kind of wonder in the familiar. What is the universe, after all, if it is not a story of constant reinvention, a testament to the power of a cosmos that is always seeking a new way to be? This ends our journey for tonight. We have traveled to a world that never was and returned with a deeper understanding of the world that is. As you slowly drift off to sleep, I'd like you to gently bring your awareness back to the place you're staying now, the time in that place at this very moment. How is it flowing? Before you close your eyes, take a moment to breathe in and breathe out a gentle reminder that even in the stillness of the night, you are a part of this grand cosmic tapestry. If you enjoyed this journey, perhaps you will join me again for another. Until then, remember to be curious, to be gentle with yourself, and to never stop asking questions. Sleep well, my companion. Wherever and whenever you are, sweet dreams.